Motors is Ryan's boss, Brian Schaefer. Brian owns the skate park and is the tournament's organizer. Brian
We had also some problems with Brian.
decides to get in on the action and try his
And trying and fail.
luck at the loop.
He gave it a few attempts, and at first he didn't make it very far, but he made a couple that I think if the pads weren't there, then he would have made it.
But as Brian continues to practice, his runs become more disastrous. The padding is pulled away, and several riders nail the loop. Now the pressure is on for Brian.
I was anxious because I wanted to do it. I was nervous because I knew how dangerous it was.
Brian takes off and falls short.
The whole crowd was like, yeah, put their hands together. Come on, Brian, go do it again. Give it another try, that type of thing. He was thinking, hey, it's now or never, and I was thinking the same thing.
Brian steps up and goes for a ride that no one will ever forget.
The impact was just tremendous. You could hear it from where I was standing. I was probably about 30 feet away. As soon as he fell, it was dead silence. And then the first thing I heard was, paramedic! I grabbed the microphone and just cleared the crowd. I just thought, like, well, maybe he'll be okay. He'll get up in a second. Until I walked up there and realized he was out. His neck was kind of crooked, and he was just laying there totally limp.
Brian's dad Bill is in the audience.
They worked on him on a ramp for a while. He was totally unconscious and looked bad. When I saw him hit the deck, I felt that he hurt himself pretty bad, just by the angle and the way he fell down. I was feeling more afraid that he would be paralyzed.
Brian's in bad shape. Medics know they must be careful with his neck. One wrong move could cost Brian his life. After they stabilize him, medics carefully wheel Brian to an ambulance and then rush to a Tampa trauma center. Incredibly, Brian suffers only a concussion and a broken hand. It was space that spared his spinal cord from massive injuries. Although the accident threw Brian's memory for a loop, he can still recall his fateful ride.
Going into it, I just remember feeling like this is the one. I come down the ramp and realizing I was a little too far to the right, which basically threw me a little off course. But I had no idea that, it would have been as dramatic or as bad of a fall as it was. But I was pretty shocked to see how fortunate I was to come out of it and not possibly being paralyzed. I think I have something to refer back to now to realize how fortunate I am and to take advantage of life as much as possible. And don't take life for granted. It would have been as dramatic or as bad of a fall as it was.
You guys notice how much he bounces?
But actually threw me a little off course.
If you're a physicist, you focus on these little weird things that most people wouldn't notice. Yeah, he bounce. Notice the body bounces quite a bit.
But I had no idea that. Basically threw me
you don't splat.
a little off course.
Of course, the helmet is the reason why he's still here.
Yeah, brutal and...
So the question is, why is that he's not able to make this loop? Why is that he's not able to loop the loop? All right, so that's what we will investigate. So this was a nice little review. All right, so the best way to solve this problem is figure out what the minimum required speed is to complete the loop. And then
But as Brian continues to practice, his runs become more disastrous.
I mean, there's a real good reason why he's not able to succeed.
The padding is pulled away, and several riders nail the...
These guys are succeeding, and Brian is not succeeding. In reality, the starting point, all of them are starting from the same point, which means that they should roughly have the same speed. And you guys are thinking the height probably matters, and you're also thinking that the weight is going to matter. And we'll check to see if either one of them is going to be a factor. All right, so the best thing to do is just to do one of those problems. Okay, so problem number 8 is the one that we're working on. So if you're a skater, obviously you're going up, and you're going to be upside down right at that point. Okay, so at the minimum required speed, when you're upside down, you're going to feel weightless. That's what it means. The reason why that happens is because the trajectory of your motion matches the curvature of the inside of the wall. Okay, so the question is, what is the minimum required speed? Okay, so let's just stop. What is the minimum required speed right at this point? All right, so figure out that minimum required speed and just exceed it. All right, so that's what the problem is all about. So what is the minimum required speed right at this point? Because at the minimum required speed, you're going to be upside down and you're going to feel weightless. All right, so here's the center of mass of this person. This person is going to have weight in this direction. And notice that it's also pressed up against the surface right here and right here. So also there's going to be a normal force in that same direction. All right, so what happens at the minimum required speed is the trajectory of this motion is going to match the curvature. All right, so it's going to match the curvature of the wall. All right, so that means that the person is going to feel weightless. Okay, so let's get the numbers. So what we have, we know that the loop is going to have a radius. It's going to be 10 feet. And so the next thing is, what is the minimum required speed to complete the loop? All right, so this is what we're trying to figure out in terms of meters per second, and then express it in terms of miles per hour. R is going to be 10 feet. All right, so which means that needs to be converted to meters. There's gravity acting on the system, obviously. So gravity is acting on the system, so right in this direction. G. Okay, so for G, I'm going to take that to be about 10 meters per second squared. All right. Okay, so that's it. Okay, so somebody do the conversion. I need R in terms of meters. And as you guys are doing that, let me draw this out one more time. All right, so the person's going to be right here. The person's going to be upside down. All right, and along the radial direction. Okay, radial direction is this way. This is the radial direction. And this could be X direction or Y direction. I don't care. I'm going to place the X direction here. There are two forces acting on this person in this direction, N and W. That's it. So what is the minimum required speed to complete the loop? So what you need to do is you need to sum up all the forces on the radial direction, the centrifugal force. So N is directed towards the center, W is directed towards the center. So N is going to be positive, W is going to be positive. And centrifugal force by definition is mv squared divided by R. All right, and R in this case is this. This is your R. All right, so that's the radius, which is 10 feet. Okay, so here's the active portion of the formula. So I'm going to rewrite the formula. I'm going to get the speed on the left-hand side. And on the right-hand side, I have W and I have N. Okay, so then we need to solve for V. We need to solve for V. Now, when you look at the question, all of a sudden there's a hint here that's going to allow us to be able to solve this problem. Here's the hint. It says when the skateboarder reaches the very top of the inside the loop, at the lowest required speed, it says the person will appear to be weightless. All right, so the person will appear to become weightless at that point. Okay, so the hint is given to us. So right at this point, right where this person is when the person is upside down, which means that this N is going to be 0. All right, so which means that this N is going to be 0. All right, so now we got the solution in a sort of weird sort of way. So what that means is at the very top of the motion, at the minimum required speed, when the person is upside down, the person is going to feel weightless. That's what it means. All right. So with that in mind, it's just easy problem to solve. All right, so here's the speed. W is mg. All right, so by definition, that's going to be mg. All right, so we got mg here. All right, so get rid of the mass. So the mass is going to cancel from both sides. And then get rid of r. So the radius is going to drop out from both sides. All right, so we have g times r. Okay, so get rid of the square by taking the square root of both sides. All right, so the minimum required speed only is going to depend on the radius of this thing. So what you need to do is you need to figure out the minimum required speed and then exceed it just a little bit. Now this thing is built with the minimum required speed in mind from the starting point of these people. Okay, these guys are starting out from here somewhere. They're starting out from here. Okay, so their starting point is usually inclusive of that. So they're supposed to do that. Okay, maybe they're starting from here. Hold on. And this is what they do. And then they should be able to complete it. Okay, so starting point should be set just so that regardless of your weight, you should be able to complete it. Okay, and notice that most of them end up squatting down. Okay, so when they bring your when they bring their center of mass, it just increases the speed somehow. All right, something we will discuss later on. Okay, so what is R? Who's done with that? Okay, got a bunch of people. Okay, 305. Cool. Those of you guys who came up with that, give yourself 5 points. So it's going to be 3.05 meters. And would you guys come up with this for this one? All right, so let me get the number for this one. This is going to be like, I don't know, 12 miles per hour. It's usually not that bad.
Yeah, it's about 12 miles an hour.
Okay, what is it in terms of meters per second?
5.52.
5.52
And that's about 12 miles an hour.
meters per second. Give yourself 10 points for that one. Yeah, if you can finish it up. That's about 12 miles per hour. Very good. Okay, so we'll wiggle this. It's going to be 12 miles per hour. Yeah, that's it, guys. It's the problem with Brian is lack of confidence. Okay, the other ones are really, really confident. And obviously they've done it a number of times. This is, you can only build up your confidence by doing it, because being upside down and feeling weightless, you kind of have to overcome your fear at that point. And he's having a really hard time because number one, if the radius is 10 feet, it should be about 12 miles per hour, right? So we got that one. But as you start to climb up and when you're upside down, you're almost feeling weightless. At that point, he's not feeling comfortable. So he started to chicken out. That's what he was doing. And then because he's so scared, he would just try to go towards the side because he thought that he was going to be able to grab it at some point. So it's the lack of confidence is the reason he was not able to execute it. Okay, it's just, he had the speed, it's just the confidence was lacking. Now take a look at the next one. All right, let's wait on this one.
But if Brian continues to...
So we're done with Brian.
Good day, man. Yeah, good.
My name's Dane Walters, and I'm a stuntman who does tumbling, gymnastics, and parkour. I'm attempting to run the loop. So I've seen people do it on skateboard before, I've seen people do it on BMX before, but no one's ever tried it on their feet, so it's been nice to be the first guy to actually run it. It looked a lot bigger than what I thought it was going to be. Yeah, I must admit, not the easiest thing I've ever done. To be one of the first people to do things is always one of my ambitions. You know, I want to try and keep pushing the boundaries even further and further and see how far people can go.
Basically boils down to this centripetal force. You need to keep on accelerating. So you need to reach a certain speed. And I've worked out, it's quite good news actually. The speed at the top is 8.65 miles per hour.
That's it.
That's it.
Okay. 3, 2, 1, go. 17.
All right, so this guy is capable of running at 17 miles per hour. That's really impressive. So it's more than, 8.5 miles per hour. So in theory, he should be able to complete the loop. But the question is, can you actually maintain that speed?
Can somebody show me that one back?
Well, this one's it. I know I've said that 3 times now, but this one is it. But I'm close, I reckon I'm close. Get close. You can't really go any further until you take the match out. Yeah, let's go for it.
Builds up his confidence nicely. That's crazy. All right, guys. The only thing I don't like about it is it's done by Pepsi. It should have been done by Coke.